All right, so on this first section, determine if the data represent a function, explain why or why not, and list the domain and range of each function, though we're only doing domain and range for 1 and 2. When I am looking at a table of values or a set of ordered pairs, what am I focusing on to determine if they are a function? If your x value repeats and has two different outputs with it. That is what we are focusing on, because remember, we say it's a function if each input has exactly one output. So we're looking at the table. So if I look at this table of values here, does each input have exactly one output? Where does that fail here? We look at I have an input of 3 here and I have an input of 3 here, but one time the function box gave me 15. The next time the function box gives me 18. Is the function box working? No, it didn't give me the same answer, so this is not a function. And our explanation, it needs to be something along the lines talking about the input of 3 has two different outputs. So when we're focusing on either a table, a mapping, or a set of ordered pairs, we're looking to see, do we have an x value that has two different y values? That is the key to, is it a function or not? Now, whether it's a function or not, it still has a domain and a range. We still have an input and an output for this. So we still have to list this. The one thing we need to remember with domain and range, we do not repeat a number. So on this one, that 3 is repeated, but when I go to write it, I'm only going to write 1, 3, -1. I do not have to write that 3 a second time. We've already accounted for 3 in the domain. And the same thing happens in the range. This one, we happen to have 2 of them that have an output of 10. I'm only going to write that 10 once and then the 15 and the 18. So it cannot be a function and still have a domain and a range, because domain is simply your x values or your input, and range is simply your y values or your output. And again, we don't duplicate values. All right, what about number 2? Does that table of values represent a function? I don't have any duplicate x values there. I have 1, 3, -1, -3. Those are 4 separate values. So this is a function. And we would say each input has exactly one output. And then in our domain, there are no repeats in our x values, so all 4 of those numbers would be in my domain, 1, 3, -1, -3. And there are no repeat values in my output, which is my range, so 3, 9, -3, -11. Now, when we're given a graph, we have to look a little differently. What do we do? How do we judge if a graph is a function? Vertical line test. Okay. If I hold my pen or pencil vertically, which is straight up and down, and I run it across the graph from left to right, am I only touching the function at one point at a time? Now, the part of that you have to remember, the vertical line would not be as wide. So think about it, am I just touching at one point at a time? I don't have 2 points at the same x. Okay. So is in number 3, does this graph represent a function? This is a function. And what could we put for our y? It passes the vertical line test. I would also accept each input has exactly one output because that's what the vertical line test is telling us. What about the graph in number 4? Does that represent a function? Yes. And again, why? Passes the vertical line test. All right, question number 5, which has like 5 parts to it, is about function notation. So yes, there is some math on your test tomorrow because there is function notation. What is the key? What are we really doing in function notation? What is f of 5 telling me to do? It's substitution. You're doing substitution. So I'm going to pause while you complete all 5 parts of question 5, and then we will come back and talk about those answers. All right, again, we have 3 different functions here. We have f of x is 3x minus 5, g of x is 2x plus 10, and h of x is x squared plus 2x minus 1. You have to match up the letter with the correct function. So for C and D, I have to use h of x. For B and part of E, I have to use g of x. And for A and the other part of E, I have to use f of x. So you do have to pay attention to the letter to make sure you're choosing the correct equation. So f of 5 means I take 3 times 5 minus 5. So 15 minus 5 equals 10. So f of 5 equals 10. In other words, when I input 5, I get an output of 10. G of negative 5 is 2 times negative 5 plus 10. So negative 10 plus 10 equals 0. So G of negative 5 equals 0. Again, these are simply substitution and order of operations problems. H of 3 squared plus 2 times 3 minus 1 is 9 plus 6 minus 1. 15 minus 1 is 14. So H of 3 equals 14. H of negative 5. This one has a square in it, so we have to make sure we put that negative 5 in parentheses. So negative 5 squared plus 2 times negative 5 minus 1 is 25 minus 10 minus 1. 15 minus 1 equals 14. So H of negative 5 equals 14. Now for E, they want you to add G of 3 to F of negative 2, which means I need to figure out what each of those are. So G of 3 would be 2 times 3 plus 10. 6 plus 10 equals 16. F of negative 2 is 3 times negative 2 minus 5. So negative 6 minus 5 is negative 11. So G of 3 plus F of negative 2 is 16 plus negative 11. So G of 3 plus F of negative 2 is 5. I have to know what the value of each function is to be able to add them together. Excuse me. Thank you. All right, the next section, similar to the activity we did yesterday, we got a little race going on here. Carlos and Jill are in an 8-mile running race. The graph below shows the distance of each racer in miles on the y-axis as a function of time hours on the x-axis. The graph of Carlos's function is represented as c of x, and the graph of Jill's function is represented as j of x. So the first part of question B there says label the graph. So they told me my y-axis is my distance, and in parentheses I'm going to put miles because they specifically said in miles. My x-axis is time, and again in parentheses I'm going to put hours because they said that's the part of time that I'm using there. And then they told me that Carlos's function is c of x and Jill's function is j of x. So we did the first part of question B there. Now I'm going to pause while you finish answering question B, C, D, E, F, and G. Give you a few minutes to answer those, and then we will check out those answers. All right, so Carlos won the race. And how do we know? Well, if we look at where Carlos was when he finished and we come down to our x-axis, he finished in 2 hours. If we do the same for Jill, took her 8 hours. So Carlos finished the 8 miles in 2 hours. While it took Jill 8 hours to complete. Over what interval is c of x greater than j of x? So after the 1 hour mark is when Carlos went ahead. So c of x is greater than j of x when the domain is parenthesis 1 comma 2 bracket. It only goes to there because Carlos finishes in 2 hours, so the domain can't go on. And what does this mean in context of the race? Carlos is ahead of Jill. If his function is greater than hers, that's saying that he is ahead. At what time approximately does c of x equal j of x, and what does that mean? And we can see right here at the 1 hour mark is where their two functions meet. So c of x equals j of x at the 1 hour mark. And what it means is Carlos and Jill are tied at this time. Then they ask C of 2. Well, if I put it 2 in my X and I go up to C of X, he finished the race in 2 hours, so C of 2 equals 8. That's when Carlos finished the race. J of 6, if I go to 6 here and I go up to where it hits Jill's function, and then I look across at my Y, so J of 6 equals 6. At 6 hours, she was at 6 miles. And if C of X equals 4, approximate the value of X from the graph. This means we have to work backwards. We know that C of X equals 4, so I have to go over to where it hits my C of X function, go down. It looks like it hits at about 1.5. So when X is 1.5, Y is 4, so we would say that C of 1.5 equals 4. And then the last questions ask about name the quadrant or axis that each point lies in or on. Just a quick little reminder of how the axes work. Quadrant 1 starts in the upper right, then we go counterclockwise for 2, then 3, then 4. And obviously if it's on an axis, it's not in a quadrant. So negative 5, 2, which quadrant would that be in? 2, because I go to the left and then I go up. 3, negative 6. 4, because I go to the right and then I go down. 0, 4. So you're on the y-axis. You did not go left or right. You just went up 4. Negative 3, negative 4. Quadrant 3, you went left and then you went down. 6, 0. X-axis, we go to the right 6, but we do not go up or down. 7, 5. We went to the right and up. Negative 2, 0. X-axis. And 0, negative 2. Y-axis. So we have to understand how ordered pairs work.